Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of epsilon delta, the definition of limits. So if you have a function that's continuous everywhere at except possibly that very point we're looking at, based on the statement limit as x approaches c of f of x equals L, we can establish a precise definition of the limit. Okay, so again, limit, we zoom into the same c value for x and then look at what's going on with y. That's conceptually what's going on. But here, down here, we have the definition that states that for every distance around that L, there is going to be a delta distance around the x value of c greater than 0. Epsilon's around the L. And such that the 0 is less than x minus c is less than delta. It's referred to as a deleted neighborhood. Includes everything but that point. C is going to be subject to f of x minus L is less than epsilon. Okay? So the main goal here is to establish the link between epsilon and delta. If you can establish that link as delta equals epsilon over k, then you're good to go. So for instance, if I were to choose some distance around this L value, and it'll be added to that L, some distance epsilon, and I could also subtract that distance epsilon from that L as well to get two corresponding values of delta around the C. So when I add epsilon, I'm going to be adding delta, right? And then the same can be said for the values when I subtract from L. Epsilon, I can also subtract delta. But again, the main point, don't get bogged down too much in the details, is to establish that relationship between delta and epsilon, namely delta equals epsilon over k. Alright? So if you can establish that link by doing the work that I will show you on the example videos, then that's pretty much what you need to know. Okay? So the main thing is to practice these. There are some exceptions to the rule, like for instance when you do a trig problem or some scenarios you won't actually have to solve for your unknown expressions. You can come up with unique relationships between delta and epsilon. So you'll only come across these if you practice these problems. Alright? So again, the main key is to get that relationship between delta and epsilon as delta equals epsilon over k. Alright? Check out the beginner, intermediate, and advanced examples to see how these are going to be worked. And as always, practice, practice, practice. More than tutoring, more than any video, doing as many of these as possible is what's important. Thank you and have a nice day.